Welcome to part 3 of Module 6. We're going to look specifically and focus in on finding probabilities when we're presented with our information organized in a table. So as I go to the next slide here, you see all of the problems we're going to work through here, all the questions down here at the bottom. And what I want you to do is to pause the video at this point and look at A, B, C, D, E, F, G, and H, and see if you can, using the table, calculate the probability. The general idea you want to follow here is look at the description, look at it very carefully, and think about which people would fall into your event space, so they would be successful picks given the description that you have. And then second, look at what the sample space would be for that particular question. Go through, write these out in fraction and decimal form. And I'm going to go ahead and pause the video right here. And then I'm going to go through and give you answers so you can check your answers with the explanations and with the information that I give you. Okay. Assuming now that you've answered all of those questions, let's take a look at the various answers. So first of all, let's start out with the probability that the person we chose is a woman. So if we look at our table, we see the total number of females is 1481. And in our sample, we have 22,506 people in total. So if we're looking at calculating the probability that a randomly selected person, and note that we are choosing just a single person in this particular problem that we're doing, and it's actually true for all of them, we would say the probability that it was a woman is equal to 1481 out of 2506. The probability then, if we find the decimal for that, 1481 divided by 2506 is 0.5610. And I'm going to see if I can make this a little bit bigger. There we go. Let's stretch it out a little bit. All right. Good. So that should be your first answer for A. For B now, let's see if I can remove this. Good. For B, we want to take into account the probability that it's a male, which of course is just the same as females, except now we're taking into consideration males. So there's 1,025 out of 2506. So as we calculate the probability of that, we're just going to divide those two numbers. Get this here. So the probability in this case is going to be 1025 out of the 2506, which gives us 0.4090 for our probability. For most probabilities on your homework, most likely they are going to be 4 decimals that you round it to. That's just a general rule. That leaves you 2 decimals. If you put it in percentage, it leaves you with 2 decimals. So that generally is how we do that. Great. Now we'll go to the next one. The probability that whoever we pick has received a master's degree. So as we look at this, and sometimes your tables are going to have totals on them, sometimes they won't, we see that master's degree recipients are here. And the total master's recipient is right here. So the probability that we would get someone that has a master's degree is really equal to the probability that they're a female master plus the probability they're a male with a master's, which gives us the total probability of being 671, again, out of the total. Adjusting my box here. So we're going to go 671 divided by 2506, which gives me a decimal value of 0.2687. Alright, and that's pretty small, so I'm going to try to highlight that and make it a little bit bigger so you can see it as well. Maybe even bigger than that. There we go. Now that's a nice good size that I like. So that is the probability that our given person would have received a master's degree. Now let's go to the next one. Now it starts to get a little more complicated. Now we're looking for the probability that it's a male or a master's degree recipient. So notice the word "or." That's something we looked at in one of the rules. The "or" always corresponds to there's two ways that we can be successful. Either they're a male or a master, or they're a male with a master. So let's look up at our column here and see if we can figure out this probability. So the master's degrees recipients we found here in the master's column. And so anyone who has a master's we would consider successful. So this entire column is part of my probability. And the other way we could be successful is that they're a male. So if I look at the row of males, we see all of these people here are males. And so therefore there's 1,025 ways we can be successful. So there's 671 master's recipients plus 1,025 males. So as I look at finding that probability, okay, we're going to take the probability that it's a male, so probability that it's a male, we know there's 671, so we have 671 out of the 2506. To that we're going to add our, I'm sorry, that's not male, that's masters. So we'll do that first. So we found the probability that it's a master's degree recipient. We're going to add to that the probability it's a male, which is 1,025 out of 2506. Now, if you noticed when we did that row and column, we double counted this number right here, the 260. So we want to uncount that, right? We counted it when we counted the 671, and we counted that same 260 when we counted the males. So we need to find the probability that the person we select would be a male with a master's, and that is 260 out of the 2506. So we subtract 260 over 2506 to get our final probability, which is, well, I'm just going to give you the percent here, 0.5730. Okay, just to point out in this problem, we didn't necessarily have to go through that, and we could have just taken all of these boxes that meet the qualifications and just added them up. In that case, we don't need to subtract because we didn't count it twice. But if we're taking totals into account, then we did overcount, and we need to take that into consideration, and so we have to do this subtraction part here. And this is just fitting with the OR formula, and I wanted to review that. And note that by subtracting it, I'm not saying that males with masters are a bad pick. What we're saying instead is that the probability, by subtracting the probability that I pick a male with a master's, I'm subtracting 260 once because it was counted twice back here. And so by doing that, I get the correct percentage. All right. The next part says, is a male and received a master's. So the way this is worded, this suggests that it is a male who has a master, right? They are male, and, which means it meets another qualification, they received a master's. Well, how many male master's recipients do we have? The number of male master's recipients we have, we saw in the previous, on D there, there are 260. So the probability that they're a male with a master's is 260. Oops. 260 out of the total recipient or total people, which is 2506. And that comes out to be, as a decimal, 0.1038. Oops. 38. There we go. All right, let's go to F now. And again, when we're thinking about how to do these problems, really think about the wording, the way it's worded. Here on F, we're asked probability that it's not a male, and now our second caveat that we throw in there, it is not someone who's received a master's. So there's two things that they cannot have. They cannot be male, and then also they cannot receive a master's. Before, when we were considering males with masters, we went right to the row and the column to get our answer. When it's not, and there's an and in between them, we can actually just ignore those two columns. So in other words, if I went through and just kind of crossed out this column and crossed out this row, that would eliminate everyone who's male and everyone who did not receive a master's. In this case, it leaves me with 3 boxes. This one, and this one. So the people who are successful picks in this case are people who are not males, meaning they're females, and people who did not receive a master's, meaning they received some other degree besides a master's. And so if we add up all those numbers, the qualification for this description is females and bachelors, females and with professional degrees, and females who are doctorates. Adding all of those up and getting the sum, we find that the probability of this column, oh geez, let's see if I can stretch that out. The probability for this column is going to be, let's go ahead and make this bigger before I type it, 0.4270. And then for the last one, this is the one where, well, it's one of the two that people get really confused on. This is saying, what is the probability if we select someone in random, they are not a male and master at the same time, right? So the not is inclusive of this, which is male and masters. When we know people who are male and masters were these 260 here. Let's erase these before I continue. The people who were male with masters were right here, 260. So if they are not that, right, then really they're going to be everything besides that. In other words, G is written different here because we are taking actually the complement of what we got in E. It is not a male with a master, so then it's anyone else, male with a bachelor's, female with a master's, everything except for males with masters. So on this one, we are going to get, if we add up all the ones except for 260, or actually just take the complement of E, we're going to get 0.8962. 0.8962. That is the probability that if we select someone, they are not a male and master's degree recipient at the same time. And then H, this is another tricky one here that I throw in here, and this is going to build into conditional probabilities when we get into the next module, Module 7. But until then, I just wanted you to think of the wording of this and to try to come up with an answer with this new sort of word that we've thrown in here, which is given. So the question is, what is the probability that they received a bachelor's given that the recipient was a woman? What does it mean when we're given something? When we're given something, it is sure that it has occurred.
right? You're given this. Given that today is Saturday, and today for me is Saturday as I'm recording this, um, anything that I say after that, we are already assuming that Saturday is the day that this is occurring. So if something is given in a problem, that changes the total possible outcomes, which is our sample space, right? If it's given that whoever we pick is a female, then we're only going to take into account females. And so it actually changes our sample space. So when we're asked, what's the probability that somebody received a bachelor's, the probability that they received a bachelor's, well, we're only going to take into account female bachelors because we're given already that we're only dealing with females. So here it changes, first of all, the top number. We don't take males into consideration. We just take the 986 females that we have, and we're going to only divide it by the number of females that we have in the study, which is 1481. When we do that division of those two numbers, we get 0.6658 as our outcome. And that is the probability that we would pick somebody that received a bachelor's. We only take into consider female bachelors now because it's given that the recipient was a woman. And we only take the women as part of the sample space. I hope this was helpful for you, and this should prepare you to go right into the next section of basically Module 6, Part 3, and to work out those homework problems. Remember that as you're going through these problems, really learning probability is when you dive in and start taking these problems on. It's the only way to learn it. Use your discussion tables and everything like that to kind of work your way through this stuff. The more that you do this, the easier it becomes. So good luck to you.